For our last video this week, I want you to just have a little bit of extra practice. So we're sort of going to put all together means and proportions. So it might be a mean, it might be a proportion. So you need to kind of figure out which one it is, check the appropriate conditions. All of the work, however, we're going to use technology for. So as I'm doing these questions with you, I'm going to be using StatCrunch. So if you would make sure StatCrunch is open, that would be great. So here are the two questions that I would like you to do. So I would like you to pause it on this screen, and I want you to try both of them. Now, of course, whatever amount of work that you choose to show is completely up to you, but this is a really good practice for you to check all of the conditions, write the hypotheses, do the calculations using StatCrunch only, so I didn't do any of these by hand, and then, of course, write our conclusion using both the confidence interval and the hypothesis test. So press pause, try both questions, then press play to check your work. For our first question, we said that a man claims to have ESP. We're designing an experiment to test his claim. You have 4 cards, spade, club, heart, diamond, and randomly choose one. So you're just taking the 4 at a time. He's choosing one of the 4, and he's going to tell you what suit you have drawn. You go through the entire deck of 52 cards and record that he got 24 correct. And then does this show that he actually has some form of ESP, or basically we're saying, is he better than what a normal person would be? Now we know that if there's 4 cards and we're randomly choosing a suit, hopefully that would be 1 out of 4 for a normal, what we're expecting. So that's going to come into play here on the hypotheses. So the checking the conditions, independence, obviously each trial has one of each suit. So whether or not he's correct each time is independent. 10%, since each trial is independent, and this could be repeated as often as we wanted, the 10% condition is met or doesn't apply. The success-fail condition, multiply NP and NQ, they're both greater than 10, and randomization, it's stated that the cards are chosen randomly. And then because the conditions are met, we will use a normal model and perform a 1 proportion Z test and interval. We're going to do both of them. Now, of course, we need our hypotheses. And if what we said before is that we would expect 1 out of 4 times for you, a normal person, to guess it correctly. So that would be a P, a probability or a proportion question, P equals 0.25. And then P is greater than 0.25, meaning this guy has special skills, whether it's ESP or not, he does better than normal. So those are our 2 hypotheses. Remember now, because this is a proportion, I have to use proportion stats. 1 sample with summary. The number of successes was 24. The number of observations was 52. And first I'm going to do a hypothesis test for 0.25 and greater than 0.25. So when I compute that, these are my values. Notice my Z statistic is 3.52, etc. My p-value is 0.002. And of course I also want to check this with a confidence interval, so with summary, and I'm going to enter those same values again. Now it asks me in this case to use what we learned about critical values to determine the appropriate level of confidence, assuming that our alpha level is 0.05. This is a one-tailed test, so if our alpha level is 0.05, I should be using the 90% interval, and remember how we computed that previously. And so again, I have found my test statistic of 3.522. My p-value is very incredibly small. I've got my lower limit and upper limit here for my confidence interval, and ended up with essentially saying that my p-value is incredibly low, so I'm going to reject the null. There's sufficient evidence that the man is correct more often than he would be by guessing. And I'm 90% confident that the man will choose the correct suit between 34.8% of the time and 57.5% of the time. Since this interval does not contain our null, it supports rejecting the null. So hopefully that all made sense to you. If you don't remember how to get that 90% as opposed to 95 or 99, go back and watch the video on critical values and alpha levels. So for our second question, we are obviously dealing with a means question because it says we're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. So this is a means question, which means when I'm checking my conditions, I'm checking my conditions for means. All of the conditions are met, so I'm going to use the student's t-model and a one-sample t-test and interval. Again, notice it's asking me to test a hypothesis and check with an appropriate confidence interval, meaning I'll have to do some calculations. If I'm using that 5%, I need to know if this is one-sided or two-sided. So if I'm supposed to get 10 ounces of coffee, but I'm saying, is there evidence that the machine is not dispensing the appropriate 10 ounces? That's not saying more than or less than. So that means my hypotheses are that it is equal to 10 or that it's not equal to 10. Of course, that's going to help me when I'm determining the confidence level, because if it's two-sided, as it is here, and I'm using a 5%, then my confidence interval should be 95%. So my calculations will all be done over here in StatCrunch. And again, I've just entered my data, and I'm going to do stat and then t stats because we're dealing with the mean. This is one sample with data. I'm using my row of, or my column of data here. And first I'm going to do a hypothesis test for 10 and for not equal to 10. And I'm going to compute. But now I also want to do it for a confidence interval. And again, 95 would be appropriate because it's two-sided, as is our confidence interval, so I'm going to compute that as well. So here are my values. Again, for a case study, I would just take a screenshot of both of those. So again, here are my p-value is very small. My interval does not contain the 10 ounces. So my conclusion, given the low p-value that I'm rejecting the null, notice that the conclusion for either the interval or the hypothesis, those two things do match up. Because 10 ounces is not in our interval, we're of course going to reject the null.